Imagine a world where humanoid robots aren't just stuck on factory floors. Picture them competing in track and field, maybe running marathons, or, get this, scoring the winning goal in a
Yeah.
football match. For years, that's felt like pure science fiction, right? Or, something way off in the distant future. But after the past 7 days, wow, the line between fiction and reality for these incredible machines has blurred. It's frankly astonishing. Welcome to Tomorrow Unveiled. Today we're diving headfirst into the incredible advancements in humanoid robotics. We're focusing specifically on the biggest breakthroughs from just this past week, a period we're definitely calling the rise of the machines. Our mission here on Tomorrow Unveiled is to distill the most crucial insights from a whole stack of diverse sources. Think cutting-edge scientific papers, detailed industry reports, all sorts of things. We want to give you a shortcut, basically, to be really well informed about how fast AI is evolving in, well, physical form.
And what makes this week, so extraordinary is that this isn't just theoretical progress anymore, not just lab stuff. We're seeing tangible, real-world development. And it was really highlighted by this pivotal event. It gave us the first large-scale public benchmark for embodied AI, like really seeing what they can do. This isn't about what robots could do in some perfectly controlled demo. No, it's about what they're actually doing right now out there in competitions and even industrial settings.
Okay, right. Let's unpack this then, because it feels like this huge shift in humanoid robotics really kicked off in Beijing.
Yeah, the first big turning point was the World Humanoid Robot Games, the WHRG 2025. It just wrapped up August 15th to 17th. You could almost think of it like the Olympics, but for bipedal machines. The information our dedicated research team gathered points to this being just monumental. We're talking 280 teams, 16 countries, and over 500 bipedal machines. Just try to picture that for a second. 500 humanoid robots all in one place, competing in all these physical challenges. And what's really fascinating, the reason the WHRG is so pivotal, well, for years, what we've mostly seen are these highly curated demos, right? Individual companies showing off carefully choreographed routines. They look impressive, sure, but they don't tell you much about true capabilities under pressure. The WHRG, though, it was designed specifically to force direct public comparison. Hardware against hardware, algorithms against algorithms, in dynamic, often unpredictable situations. It wasn't just a showcase, it was more like a brutal stress test. And maybe even more importantly, the games were explicitly set up as this massive systematic data gathering exercise. Every stumble, every perfect run, every decision made on the field, all of it was fed into this giant data set. It basically turned the competition into a data flywheel. And this real world performance data, it's absolutely essential fuel for training the next generation of AI models.
And the athleticism we saw, I mean, it was genuinely eye-opening. The Unitree H1 humanoid robot particularly was just a standout performer in the track events. It grabbed gold medals in the 1,500-meter run. Get this, 6 minutes, 34 seconds. Also the 400-meter, the 4x100 relay, and even the 100-meter hurdles.
Yeah.
It's wild to think of a robot clearing hurdles.
Yeah, the Unitree H1's dominance isn't just about raw speed or being agile. It demonstrates exceptional energy efficiency, really remarkable thermal management. I mean, it can run hard without overheating, which is huge. And crucially, robust dynamic stability over extended periods. It doesn't just fall over after a minute. These are absolutely fundamental capabilities if you want practical real-world deployment, right? Robots need to operate for more than just a few minutes without breaking down or, tipping over. Now, while Unitree H1 really excelled at that endurance side, the Tiangong Ultra showed off pure, blistering speed. It won the 100-meter sprint in just 21.50 seconds. That win really highlights superior peak power delivery and incredibly refined control algorithms, specifically for high-speed motion. That's another vital piece of the puzzle for making these robots truly dynamic.
Okay, but here's where it gets really interesting for me. The multi-agent stuff, the coordination. The
Yeah.
robot football final, a 5-on-5 match, was just a compelling case study. Single University's Hafiz's team won 1-0. And the winning goal is this impressive long-range shot. I mean, it's hard enough for humans to coordinate on a soccer field, let alone 5 bipedal robots.
And that winning shot, it's actually far more significant than just one goal. It represents a sort of nascent but really crucial step towards effective multi-robot teamwork. Think about what's involved. You need real-time perception to see the ball in the goal accurately. Then complex decision-making. Should I shoot long? Should I pass? And then precise motor execution to actually deliver that powerful kick, all while other robots are moving around. It's a really vivid glimpse into sophisticated goal-oriented behavior starting to emerge from these machines.
Yeah, absolutely. And beyond the spectacle of the sports, the games also had these very practical events. Things like material handling, drug sorting, cleaning services. You mentioned those are crucial for near-term viability. What exactly stands out about those less dramatic tasks.
Well, it's funny, isn't it? These seemingly less dramatic tasks are, ironically, incredibly important. The insights from our source material really emphasize that they're crucial leading indicators for near-term commercial viability. If robots can handle these sorts of structured tasks reliably, efficiently, and, importantly, safely, it points directly to their potential in places like warehouses, logistics centers, maybe even hospitals. Imagine a robot sorting medications accurately or moving supplies around a factory floor just like a human could. It's not as flashy as a 100-meter sprint, maybe, but it's arguably more impactful for immediate deployment.
Absolutely. But, okay, despite all these impressive feats, the games also gave us a very clear reality check, didn't they? The information we reviewed notes there were still, frequent stumbles, lots of falls, and often a need for human help just to get robots back on their feet. It showed that while moving around is advancing incredibly fast, there's still a big hurdle with, finer interactions.
Yeah, that's a key takeaway. So if they're running marathons and playing football, why are they still sometimes stumbling or needing help with basic tasks? It paints a very real picture. Locomotion, walking, running that's advancing rapidly. But manipulation capabilities seem, well, pretty rudimentary by comparison.
Ah, okay. So you've hit on this critical imbalance. Their ability to run, keep balance, even get up after falling has improved remarkably. That's clear. But tasks needing fine-grained manipulation, picking up small objects, using complex tools, even just opening a standard door, those are still significantly challenging.
Exactly. That tells us that dynamic bipedalism, just moving effectively on two legs, has been the primary focus of R&D so far. And it suggests that dexterous manipulation, using hands and fingers effectively, is clearly emerging as the next great frontier for robotics engineers.
So how are they getting these machines so smart and capable?
Yeah.
It sounds like it's this mix of incredible progress in both their brains, the algorithms, and their bodies, the hardware. What's really driving this rapid leap forward? Is it mostly about advances in just raw hardware power, or are the breakthroughs in their brains the real game changer here?
Well, it's definitely a synergy. You can't really separate them entirely.
Yeah.
But the algorithmic advances are fundamentally changing how we even approach controlling these things. We're moving beyond these sort of brute force AI approaches towards much more structured, more efficient methods. And that's making the notoriously difficult problem of humanoid control far more tractable, more robust.
And the research team that compiled this information for us, they pointed to several key frameworks that really illustrate this shift. First, there's something called the M-ASH framework. Am I getting that right?
Yep, M-ASH.
Okay, so M-ASH treats each of the robot's limbs as kind of independent agents, but they're within a cooperative learning system. So they learn together, which speeds up training and improves the overall synergy. Is that the idea?
That's basically it. It helps coordinate complex movements.
Okay. Then there's symmetry equivariant policy, or SE policy. This one sounds fascinating. It's like instead of the robot learning every single step from scratch when learning to walk, SE policy sort of bakes in the fundamental understanding that a human-like body is symmetrical. Left mirrors right.
Exactly. That inherent sense of balance or symmetry is embedded directly into its neural network. It makes its movements much more coordinated, stable, and efficient right from the get-go. It's like giving the robot an intuitive grasp of its own body mechanics. One study showed something like a 40% improvement in velocity tracking accuracy using this.
Wow. Okay. And for navigation, there's end-to-end safe and comfortable locomotion. This uses raw LiDAR data, that's the light-based radar, right?
Right.
Creating a 3D map.
Precisely.
So it uses that LiDAR data to map directly to motor commands. It doesn't just avoid crashing into things. It uses these comfort-oriented rewards to make its movements feel more socially aware, less threatening to us humans.
Yeah, think about a robot moving through a crowded room. It wouldn't just barge through. It tries to move in a way that feels natural, non-intrusive, predictable, more comfortable for the people around it.
That makes sense. And maybe the most intriguing one, the Robot Trains Robot, RTR, framework. This actually uses a teacher robot arm to physically guide and support a student humanoid robot during real-world training.
It does. It's a clever way to ensure safer, more efficient learning directly on the hardware. It really speeds up that whole iterative process of teaching robots new physical skills without constant failures or damage.
Okay, so these algorithmic breakthroughs are huge.
Yeah.
But they only work if the hardware can keep up right.
Absolutely. They're only half the story. You need incredibly powerful hardware platforms to actually execute these complex instructions in real time. The Unitree H1, which we talked about dominating the track, that's a perfect example.
Yeah.
Our analysis showed it has these incredibly strong proprietary joint motors. We're talking around 360 newton meters at the knee.
Which is a lot.
Oh, yeah. To put that in perspective, that's enough torque to lift a significant weight or provide serious thrust for jumping and running. It's what makes it so dynamic. Plus, it's got that 3D LiDAR system we mentioned, a depth camera for really comprehensive 360-degree perception,
Yeah.
and powerful onboard computing like an Intel Core i7 to process it all.
Okay. And the other standout, the Tiangong Ultra, the Sprinter.
Right. That one, noted for its pure speed, boasts high-precision vision sensors and an astonishing 550 TOPS processor.
550 TOPS.
Trillion operations per second. 550 trillion operations per second.
Wow.
Yeah. That allows for incredibly fast, real-time decision-making and reaction speeds, essential for stable running in dynamic environments.
So these hardware advances really give them the raw power, the senses, the computational muscle they need for these sophisticated algorithms to actually work. It's truly a partnership between the brain and the body.
Exactly. And the culmination of all this, these algorithm and hardware advances, is leading to this fascinating AI architecture for embodied intelligence. Our research team has sort of conceptualized it as a big brain and little brain approach.
Okay, big brain, little brain. What's the difference there? How do they work together?
Well, think of it like this. The big brain is made up of these general-purpose systems. They handle the high-level stuff: semantic understanding, long-horizon planning, common-sense reasoning, basically figuring out what needs to be done over longer timescales. An example from NVIDIA is their Cosmos Reason model. It's a huge 7 billion parameter vision language model. The goal is to give robots common-sense understanding of the physical world, helping them plan really complex multi-step tasks, like clean the kitchen. And another system, Cosmos Transfer 2, is designed to accelerate synthetic data generation. That means creating vast amounts of virtual training data to rapidly teach robots new skills without needing endless real-world trial and error, which is slow and expensive.
Okay, so the big brain is the high-level strategist. It understands the goal, the what, and the why. And the little brain.
The little brain is made up of highly optimized, specialized policies. These handle the low-level, high-frequency motor control. Think of them as the reflexes, the precise, fast movements needed in the moment. Like algorithms such as humanoid kick, which allows for those dynamic, reactive kicks in robot football, that split-second adjustment to score. Or something like the P30 CBF controller, which focuses on ensuring safe and comfortable navigation by managing the robot's immediate interaction with its environment, second by second. The future, I really think, lies in the seamless, elegant integration of these two layers. You'll have a generalist big brain providing goals and context, feeding instructions to a collection of specialist little brain motor controllers that handle the granular, real-time execution.
This all sounds like we're moving incredibly quickly now. From those isolated lab demos to genuine real-world applications. Is that truly what's happening? Are we seeing these systems actually leaving the labs and, entering our daily lives or workplaces?
We absolutely are. And one of the most significant validations of this trend comes straight from the research we've gathered. Zoomlion, which is a major Chinese heavy industry giant, has already begun deploying humanoid robots in its actual manufacturing facilities. And this isn't just a tiny pilot program with 1 or 2 robots testing the waters. No, this looks like one of the most significant real-world commercial deployments we've seen to date.
Wow. And the details our team found are fascinating. Zoomlion has dozens of units running already, including both 2-wheeled models and at least 1 bipedal model in pilot operations right now. And they're doing everything: machining, logistics, assembly tasks, even quality inspection. These robots apparently feature full-scene multimodal perception so they can see and interpret complex surroundings. They have precision grasping and even dual-arm collaborative motion planning with safety protocols built in, which allows them to work effectively and presumably safely right alongside human workers.
Yeah, and this significantly accelerates the plausible commercialization roadmap, doesn't it? In the near term, say the next 1 to 3 years, we're likely going to see more and more deployments like this, especially in structured environments. Think warehouses, factories, logistics centers. Their ability to potentially operate with human tools gives them this tremendous advantage. They can integrate into existing infrastructure rather than requiring entirely new robot-specific setups.
So they could potentially just walk into an existing factory or warehouse and more or less get to work. Maybe even using the same drills or carts humans use. That's quite a leap.
Precisely. That's the promise anyway. However, while that near-term picture looks increasingly promising, long-term deployment, maybe 5 to 10 years out, in really unstructured human environments, homes, public spaces that still faces some formidable challenges. The information we've analyzed consistently highlights a few key things. Robustness is one.
Meaning they don't break down easily.
Right. Can they perform reliably, day in, day out, without constant maintenance? That's still a question mark. Then there's energy efficiency, all-day operation on a single battery charge. Still largely out of reach for these complex machines. And of course, cost remains a persistent hurdle. These things are still very expensive. Although, interestingly, China's strategic focus on building a domestic supply chain for all the key components, that's clearly an attempt to drive down those costs and achieve economies of scale faster to make them more accessible.
Okay, so as these machines get smarter, more capable, and increasingly human-like, well, they also start pushing us into some very deep ethical waters, don't they?
Yeah.
Our research team uncovered a truly provocative development this week. A company called Kaiwa Technology stated its goal is to develop a pregnancy robot by 2026, integrating an artificial womb into a humanoid chassis.
Yeah.
So for our listeners trying to wrap their heads around this, what does this development, even just as a stated goal, truly mean for society?
Well, this development, and let's be clear, is still speculative and certainly controversial. It raises just profound questions. It forces us to consider things like the potential commodification of childbirth, the very nature of parenthood, maternal bonds, and fundamentally the redefinition of core biological processes that have, until now, always been uniquely human, right? I mean, when humanity can potentially externalize its most intimate biological functions, what then defines us? Is it just the act of creation, or is it something deeper about our consciousness, our connection? This isn't just a technical marvel to debate. It really prompts a fundamental redefinition of what it means to be human. And that conversation, frankly, needs to accelerate right now.
Yeah. And it's clear the regulators are already discussing policies around these kinds of developments, which just highlights that these aren't hypothetical far future discussions anymore, are they? The technology is advancing so rapidly, it's demanding a proactive societal conversation about its boundaries and its implications. These questions aren't for decades from now, they're really for today. So wrapping things up, this past week truly feels like a significant inflection point for humanoid robotics. We've seen this rapid transition from, isolated demonstrations to public competitive validation and even tangible real-world commercial applications starting. The synergy between these robot games, innovative industrial uses, and that cutting-edge academic research. It's all dramatically accelerating what we're calling the rise of the machines.
And just to connect this to the bigger picture, the breakthroughs we're seeing in humanoids specifically, particularly those pushing the boundaries of human-like form and function, they actually have the potential to solve some of the most difficult control problems in robotics generally. It's not just about humanoids. The principles discovered while chasing stable bipedalism or multi-contact planning or high-dimensional control. Those insights could actually trickle down and improve many other less complex robotic systems. Solving the really hard humanoid case isn't just about making better humanoids. It's about developing master algorithms for physical intelligence across the board, which will ultimately benefit every type of robot out there.
It's a truly fascinating time to be alive, isn't it? Seeing these machines literally step into our world. And it leaves us with a big question to ponder. As machines increasingly mirror human form and capability, and maybe even start taking on roles once considered uniquely human, how will our understanding of what it means to be human evolve right alongside them? Now, if you're finding this insightful and you're watching on YouTube, please take just a moment to like this video. Subscribe to Tomorrow Unveiled, and be sure to turn on notifications so you never miss an update on the future unfolding.
Yeah, and if you're listening on a podcast service, maybe Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It genuinely helps us reach new listeners who are curious about these topics.
And we really do love hearing your thoughts. Whether you're on YouTube or your favorite podcast app, leave a comment. Let us know what you think about this rise of humanoid robots. What excites you? What concerns you? We'll see you next time on Tomorrow Unveiled.